head loss per 1,000 feet of pipe, I believe. So right now there's a lot of flow going through here. I can see my flow is 1,700 through there. Because this is such a longer route, there's less flow going through it. If I just right click on this pipe and I actually just click on this pipe 13 and I go up here and I close it, and now I run my simulation again, I'll see now I have negative 392 psi at that node. Things just got a lot worse. Okay. So for this particular exercise, you do not have to put another pipe between the tank and this node. I just want you to solve this problem down here. Yes, in theory, you'd need 2 links because this pipe could be out of service. We're going to not worry about that for the time being. We're going to just worry about the stuff down here. So your task is, you've got this fire. This is the problem that we're looking at right now. You have to test it with this pipe out of service and try to solve this so that there's 20 psi everywhere. You can draw in new pipes. You can change pipe diameters. Think through, if this was a real life situation, this was the existing network under the ground, and you're tasked with solving this problem. Okay, what would be better? Let's look at this pipe, 2,000 feet, 6-inch pipe. What would be better, replacing that pipe with a 12-inch pipe or adding a 12-inch pipe in parallel? Is there a big cost difference between those two? Not really. You still need to dig it up, you still need to buy the pipe, and you still need to lay the pipe. If I replace that pipe with a 12-inch pipe, I still only have 1 pipe there. So now if it's closed, I lose. But I can just lay it in parallel, it costs almost the same amount, and now I've got parallel pipes, a 6-inch and a 12-inch. Now if the 12-inch is out of service, I still need to be able to meet my pressure requirements. So maybe that's not a solution in and of itself. Maybe I need to put parallel 12-inch pipe here and here. Maybe I need to draw a new one from here to here or from here to here. However you decide, there's lots of different solutions to this problem. I just want you to think through, in reality, what is a good solution, and then test it. And you may need to test it with this pipe closed, then you need to test it with this pipe closed, or this pipe closed, or any other pipe in the system. You need to use your intuition. You're not going to go through and actually test every single pipe, because like this pipe, you know, is not going to be critical. Okay, so you need to use your intuition and your understanding of the model to test the key links that you think are going to be required to be upgraded or changed. For this exercise, when you solve that problem, there are going to be other nodes in the network that could still fail if you had a fire at them. You don't need to simulate a fire everywhere. All I'm asking you to do is simulate the fire here, solve that problem, and then show me an image of the EPANET network showing the diameter of each pipe and the pressure at each node. So you'd go up to nodes, show the pressure. You go to links, you'd show the diameter. Please try to not have things be in yellow when you print them, or I can't really see what they say. So you're gonna have to change your color so that there's no yellow. Light blue I can usually make out. You can also change the size of these things. If you go back to the view options, I can change my font size of, say, my nodes to be more visible. And then I can either do like a screenshot of this or I can actually print what I'm seeing. A snipping tool, screenshot, whatever is fine as long as I can make out what's going on. And as long as I can see, okay, the pressure everywhere is 20, and I can see your pipes and what the diameters of them are, so I know what your solution to the problem was. So that's number one. Number two on here, I have you just set up a new network. Figure 12.6.3 in your book, which I have my book here in case you didn't bring yours, because I assume most of you didn't. There's a figure here. I want you to set up that in EPANET and run it and show me the results for that. There's a little note on there that for that one, EPANET won't let you run a simulation if there is no reservoir anywhere in the network. And this figure in your book has no reservoir. So it just has a note to say, add a reservoir, connect it with a link to this, and then close that link. So it's not participating, but now it can actually solve the problem. Okay? Is there any questions on anything? Yeah.
One of those keys went away that has all the colors.
If you hit View Legends, there should be little check marks. Did you have a question? Same one? Different one.
Yeah, so for the first one, it's 20 psi at every node in the square system, or like the nodes over 5
For all the ones in here, yeah, don't worry about this guy. This guy is going to occasionally have pressures less than, or it might always have pressures less than, but I'm not worried about that. I'm worried about where there's a demand. Yeah. Any other questions?
Do you have the ability to just place a node in the middle, like that long pipe?
Uh-huh. Yes. Yeah, you'd have to create a junction. You could just create it right up here, because it doesn't matter if the pipes are at an angle or whatever. Just place the junction, delete that pipe. Or another little shortcut is, this is node 19. I could take this pipe, and it says start node 14, end node 15. I could change its end node to 19, and it'll connect 19. And then I could just draw a new one there, and then I just need to change the two lengths. All right, so the rest of the lab period is just for you to finish up number 1 and number 2. It shouldn't take you too long, and then you can hand these in whenever. They're technically due next Wednesday. If you want to hand them in today, you can, or in class tomorrow, my box, whatever, it's fine.